They believed their fortress was impregnable, carved into volcanic rock, reinforced with steel and concrete, defended by Japan's most elite garrison. The coastal stronghold of Kaigun-jima had never fallen to enemy assault. Its commanding position overlooking the Pacific shipping lanes made it the crown jewel of the empire's outer defense ring. The soldiers manning its guns had been told that no force on earth could breach their walls, that their sacrifice would buy precious time for the homeland. They were wrong. But before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. On the morning of October 14, 1944, something appeared on the horizon that changed everything. What the defenders witnessed in those first moments would shatter not just their fortress, but their entire understanding of modern warfare. The question that haunts military historians to this day is simple yet profound. How did a single naval engagement transform the Pacific theater forever? When an immovable object meets an unstoppable force, theory becomes reality in the most violent way imaginable. In the waters off Kaigun-jima, that collision would rewrite the rules of siege warfare and prove that even the most formidable defenses could crumble before the raw power of American naval engineering. To understand the magnitude of what happened on that October morning, one must first comprehend the nature of the fortress itself. Kaigun-jima, literally Navy Island in Japanese, was no ordinary military installation. Rising from the Pacific like a jagged tooth, this volcanic outcrop had been transformed over 3 years into what Japanese military engineers proudly called the Gibraltar of the Pacific. The island measured barely 2 miles in length and half a mile at its widest point, but every square foot had been weaponized. Massive coastal defense guns, each weighing over 40 tons, were embedded deep within reinforced concrete casemates carved directly into the living rock. These were not hastily constructed field fortifications, but permanent installations designed to withstand everything the enemy could throw at them. The main battery consisted of 6 16-inch naval rifles, repurposed from battleships and mounted in armored turrets that could rotate to engage threats from any direction. Colonel Hiroshi Yamamoto, the fortress commander, had overseen the construction personally. A veteran of the Russo-Japanese War and a student of European fortress design, he understood better than most how to create an impregnable position. The gun emplacements were connected by a network of tunnels blasted through solid basalt, each passage reinforced with steel beams and concrete thick enough to stop the heaviest bombs. Living quarters, ammunition storage, communication centers, and medical facilities were all buried deep underground, protected by dozens of feet of rock and reinforced concrete. The garrison itself reflected the fortress's importance. Rather than conscripts or second-line troops, Kaigun-jima was defended by the 3rd Special Naval Landing Force, Japan's equivalent of elite Marines. These men had been handpicked for their skill, their loyalty, and their willingness to die rather than surrender. Many were veterans of the early Pacific campaigns, hardened by battles across the Central Pacific. They knew their weapons intimately, had drilled endlessly in the fortress's corridors, and possessed an unshakable faith in their position's invincibility. Fortresses were maintained by submarines and fast destroyers that made high-speed runs under cover of darkness. The island was entirely self-sufficient, with underground cisterns holding enough fresh water for 6 months and ammunition bunkers stocked with thousands of shells for the main guns. Even if completely cut off, the garrison could hold out indefinitely, or so their planners believed. The psychological impact of the fortress extended far beyond its military capabilities. To the Japanese high command, Kaigun-jima represented the indomitable spirit of the empire itself. Here was proof that Japanese engineering, Japanese courage, and Japanese determination could create something truly unassailable. Foreign observers who had visited before the war declared it the most formidable coastal fortress they had ever seen, comparing it favorably to the great European fortifications of Verdun and the Maginot Line. This reputation was not built on propaganda alone. Early in the war, American submarines attempting to reconnoiter the island had been driven off by accurate and devastating fire from the coastal guns. Several had been damaged, one had been sunk outright. Long-range bombing raids had proven equally ineffective,
with the fortress's anti-aircraft defenses claiming dozens of enemy aircraft while suffering minimal damage in return. The thick concrete and solid rock absorbed bomb impacts that would have leveled conventional structures. By the autumn of 1944, Kaigun-jima had become a symbol throughout the Pacific theater. To the Japanese, it embodied their ability to hold key positions indefinitely despite overwhelming enemy numbers. To the Americans, it represented a nearly insurmountable obstacle, a fortress that would require massive casualties to capture and might not fall even then. Intelligence estimates suggested that a conventional amphibious assault would cost tens of thousands of lives and might ultimately fail entirely. The fortress's designers had anticipated every conceivable form of attack. Underwater obstacles and mines protected the approaches. Beach defenses were layered in depth with interlocking fields of fire. The main guns could engage surface targets at ranges exceeding 20 miles, while secondary batteries provided close-in defense against landing craft. Even if attackers somehow reached the shore, they would face a nightmare of tunnels, bunkers, and prepared positions defended by fanatic troops who preferred death to dishonor. What they had not anticipated, what no one in the Japanese military hierarchy had seriously considered, was the possibility that the Americans might develop weapons capable of reaching into their deepest bunkers and destroying installations that had been deemed impregnable. The fortress had been designed to withstand the heaviest naval bombardment anyone could imagine in 1942. By 1944, American industrial capacity and technological innovation had rendered those assumptions obsolete. Colonel Yamamoto himself embodied the confidence that permeated his garrison. A small, precise man with steel-rimmed spectacles and a meticulously groomed mustache, he had spent his entire adult life preparing for this moment. His quarters, carved into the rock 50 feet below the surface, were Spartanly furnished but immaculately maintained. Maps covered every wall, showing not just the fortress itself, but the broader Pacific theater and the locations of American forces. He studied these maps for hours each day, calculating ranges, analyzing approach routes, and planning how to make the enemy pay the highest possible price for every inch of his island. The colonel's daily routine never varied. Each morning, at precisely 0500 hours, he would inspect the gun positions, reviewing maintenance reports and checking the condition of equipment. The massive naval rifles were cleaned and calibrated daily, their crews drilled relentlessly in loading procedures and target acquisition. Ammunition was rotated regularly to ensure maximum reliability, with older stocks used for training while the newest shells were reserved for actual combat.
Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now back to the story. Actual combat. Every detail received his personal attention, for Yamamoto understood that in fortress warfare, preparation was everything. His men shared their commander's confidence. Veterans of successful actions across the Pacific, they had seen American forces repulsed before. They knew their weapons, trusted their fortifications, and believed absolutely in their cause. The garrison included not just gun crews, but specialists of every type. Radar operators who could track targets at extreme range, communications personnel who maintained contact with the mainland, engineers who continuously improved the defenses, and medical staff prepared to treat casualties while continuing to fight. The fortress's supply situation reflected this same meticulous preparation. Deep storage bunkers held not just ammunition, but spare parts for every weapon system, medical supplies for extended casualties, and rations for a siege lasting many months. Fuel tanks carved into the rock powered generators that kept the fortress's electrical systems running, while backup systems ensured that critical functions could continue even under the heaviest bombardment. Fresh water came from springs deep within the island, supplemented by filtration systems that could process seawater if necessary. Even entertainment and morale had been considered. The garrison's quarters included a small library, recreation areas where off-duty personnel could relax, and even a shrine where the men could pray for victory and remember their fallen comrades. Letters from home were treasured possessions, read and reread until they fell apart, connecting these isolated defenders to the families and nation they served. Many of the men had not seen Japan in over a year, but their dedication never wavered. As October 1944 began, the fortress seemed as impregnable as ever. Recent intelligence reports suggested that American forces were massing for major operations elsewhere in the Pacific, but Kaigun-jima appeared to be holding its position as a key strongpoint in the Empire's defense network. Routine patrols by submarines and aircraft reported no unusual enemy activity in the surrounding waters. The daily radio communications with headquarters in Tokyo continued without interruption, carrying routine reports of readiness and morale. Colonel Yamamoto's final inspection before the battle was typical of his methodical approach. He visited every gun position, spoke personally with section leaders, and reviewed the latest intelligence summaries. Everything appeared normal. Everything was ready. The fortress that had never fallen prepared for another day of vigilant defense, its garrison confident that they could meet any challenge the enemy might present. What they could not know, what their intelligence networks had failed to detect, was that 400 miles to the southeast, the most powerful naval force ever assembled was already heading their way. The American task force approaching Kaigun-jima represented not just overwhelming firepower, but a fundamental revolution in the nature of naval warfare itself. The collision between old certainties and new realities was only hours away. The American challenge. Admiral William Bull Henderson stood on the bridge of USS Thunderbolt, his flagship, watching the Pacific horizon through powerful binoculars. Unlike the confident garrison awaiting them on Kaigun-jima, Henderson faced a problem that had kept him awake for months. The fortress ahead represented everything wrong with conventional military thinking. It was too strong to assault, too well positioned to bypass, and too important to ignore. Henderson was not a typical naval commander. While most of his peers had risen through the traditional ranks of battleship and cruiser commands, he had spent the early war years working with the Navy's Bureau of Ordnance, helping to develop new weapons and tactics. This experience had given him a unique perspective on the challenges facing American forces in the Pacific. He understood better than most that the old methods of naval bombardment, effective against field fortifications and beach defenses, were woefully inadequate against modern fortress construction. The task force, under his command, reflected both the strengths and limitations of American naval power in late 1944. At its heart were four of the newest Iowa-class battleships: Thunderbolt, Sovereign, Intrepid, and Resolute. These were among the most powerful warships ever built, each mounting 9 16-inch guns capable of hurling shells weighing nearly a ton across ranges exceeding 20 miles. Their armor was the thickest ever mounted on an American vessel, their speed unmatched by any other battleship in the world. Supporting the battleships were 6 heavy cruisers and 12 destroyers, along with a small fleet of supply vessels, ammunition ships, and specialized support craft. The entire force represented an investment of billions of dollars and the efforts of hundreds of thousands of workers in shipyards across America. Yet for all its power, the task force faced a fundamental problem. How do you destroy targets that have been specifically designed to withstand everything you can throw at them? Previous attempts to neutralize heavily fortified positions had yielded disappointing results. The bombardment of Japanese positions on Tarawa had required massive expenditures of ammunition while achieving limited tactical success. Even the newest and most powerful American shells struggled to penetrate the thick concrete and solid rock construction that characterized modern fortress design. The standard procedure of systematic bombardment followed by amphibious assault promised to be both expensive and bloody when applied to a target as formidable as Kaigun-jima. Henderson's solution had emerged from months of collaboration with scientists and engineers at the Naval Research Laboratory. Rather than simply accepting the limitations of existing weapons, his team had asked a more fundamental question: what would it take to destroy any fortification, regardless of how well it was built?
The answer lay not in bigger guns or more ammunition, but in understanding the physics of explosive force and the structural limits of even the strongest materials. The breakthrough had come from an unlikely source: seismology. Scientists studying earthquake damage had discovered that certain types of shock waves could cause catastrophic structural failure even in buildings designed to withstand tremendous forces. The key was not the total amount of energy delivered, but how that energy was transmitted through solid materials. A properly designed explosive charge delivered to exactly the right location could bring down structures that would survive much larger but less precisely applied forces. Translating this theoretical knowledge into practical weapons had required months of intensive development. Working with ammunition manufacturers, Henderson's team had created a new type of naval shell that bore little resemblance to traditional high-explosive projectiles. These new rounds, designated bunker buster shells by their creators, were designed to penetrate deep into fortified structures before detonating. Rather than relying on surface blast effects, they delivered their explosive force directly into the structural heart of their targets. The shells themselves represented a masterpiece of engineering. Each 16-inch projectile weighed nearly 2,700 pounds, but this weight was distributed very differently from conventional ammunition. The nose section was solid steel, hardened and shaped to penetrate concrete and rock through pure kinetic force. Behind this penetrator was a delayed action fuse system that could be programmed to detonate after varying degrees of penetration. The warhead itself contained a new type of explosive that generated shock waves specifically tuned to cause maximum structural damage. Even more revolutionary was the fire control system that would guide these weapons to their targets. Traditional naval gunnery relied on direct observation and relatively simple ballistic calculations. The ranges and precision required for effective fortress bombardment demanded something far more advanced.
Sophisticated. Henderson's ships carried the latest radar-directed fire control computers, mechanical marvels that could calculate firing solutions while accounting for wind, temperature, the rotation of the Earth, and dozens of other variables that affected projectile flight over extreme distances. The men who would operate these systems were as carefully selected as the weapons themselves. Gunnery officers had been chosen for their mathematical aptitude and technical training rather than simple experience. Gun crews had drilled endlessly with the new ammunition, learning to load and fire the heavy projectiles with clockwork precision. Fire control technicians had mastered the complex radar and computing equipment that would be essential for accurate long-range engagement. Captain James Mitchell, Henderson's chief gunnery officer, embodied this new breed of naval warrior. A graduate of the Naval Academy's engineering program, he had spent the early war years helping to design the fire control systems now installed on the task force's battleships. Unlike traditional gunnery officers who relied primarily on experience and intuition, Mitchell approached his profession like a scientist, analyzing every variable and calculating optimal solutions for each tactical problem. The approach to Kaigun-jima had been planned with the same scientific precision that characterized the weapons themselves. Rather than the traditional close-range bombardment that maximized the number of shells that could be delivered, Henderson's plan called for the task force to remain at maximum effective range throughout the engagement. This would deny the fortress's guns any opportunity for counter-battery fire while allowing the American ships to engage with maximum precision and minimum risk. Intelligence gathering for the operation had been equally methodical. Rather than relying solely on aerial reconnaissance and submarine reports, Henderson's staff had analyzed captured Japanese construction documents, interviewed prisoners familiar with fortress construction techniques, and even consulted with civilian engineers who had worked on similar projects before the war. Every detail of the target's construction had been studied, from the thickness of concrete walls to the depth of ammunition bunkers. The ammunition load for the operation reflected this intelligence. Rather than the mixed loads of high-explosive and armor-piercing shells typically carried by battleships, Henderson's vessels carried almost exclusively the new bunker buster rounds.
Each ship carried enough of these specialized projectiles to sustain bombardment for hours, with additional ammunition ships standing by to replenish their magazines if necessary. The logistics of this operation were staggering, requiring the coordination of dozens of vessels and thousands of personnel across vast distances of ocean. Weather conditions for the attack had been carefully monitored for weeks. The bombardment would require near-perfect visibility and calm seas to achieve the precision necessary for success. Meteorologists attached to the task force had identified a narrow window of optimal conditions, and Henderson had positioned his ships to take advantage of it. Every detail had been considered, every contingency planned for. Intrinsically linked to this deliberation was the psychological preparation of his crews. These men understood that they were participating in something unprecedented in naval warfare. The success or failure of their mission would determine not just the fate of Kaigun-jima, but the future direction of American naval strategy in the Pacific. The weight of this responsibility was balanced by confidence in their training, their equipment, and their leadership. Unlike the Japanese garrison, which drew its strength from tradition and unquestioning loyalty, Henderson's force represented the American military at its most innovative. These were men who asked questions, who challenged assumptions, who sought technological solutions to tactical problems. They brought to their mission not just overwhelming firepower, but the intellectual
flexibility to use that power in ways their enemies could not anticipate or counter. As the task force approached its firing position, Henderson reflected on the magnitude of what they were attempting. Naval bombardment of coastal fortifications was as old as gunpowder itself, but what they planned was something entirely new. They were not simply going to shell the fortress until it surrendered. They were going to systematically destroy it from the inside out, using weapons and techniques that no defender had ever faced before. The contrast between the two forces could not have been more complete. On Kaigun-jima, defenders prepared to resist attack using methods and mindsets that had changed little since the Russo-Japanese War. 400 miles away, an American task force approached with weapons and tactics that would have seemed like science fiction to military planners just a few years earlier. The collision between these two philosophies of warfare was about to begin. The moment of truth. The morning of October 14th dawned clear and calm across the Pacific, with visibility extending to the horizon and seas running no more than 2 feet. These were perfect conditions for precision gunnery, exactly what Admiral Henderson had hoped for when planning his approach. At 0530 hours, as the first light of dawn touched the volcanic peaks of Kaigun-jima, the American task force reached its firing position 32 miles southeast of the fortress. Colonel Yamamoto received the first reports of approaching ships at 0545 hours. His radar operators, scanning their screens in the underground operations center, had detected multiple large contacts bearing southeast at extreme range. The size and formation of the contacts suggested a major American task force, but their distance seemed to indicate they were simply passing through the area rather than preparing for attack. No naval commander in his right mind would attempt to engage a coastal fortress from such an extreme range. The colonel's initial assessment was cautious, but not alarmed. American forces had appeared at long range before, usually conducting reconnaissance or testing the fortress's radar coverage before withdrawing. Standing orders were to track such forces, but avoid revealing the full capability of the island's detection systems unless actually under attack. Yamamoto ordered his gun crews to man their stations as a precautionary measure, but did not sound general quarters or activate the fortress's complete defensive systems. This decision reflected both the limitations of Japanese naval doctrine and the confidence that 3 years of successful defense had built within the garrison. Every previous encounter with American naval forces had followed predictable patterns: reconnaissance at long range, withdrawal when engaged, or close-range attacks that could be driven off by the fortress's heavy guns. The possibility that an enemy might possess weapons capable of engaging effectively at 30-mile ranges had simply never been seriously considered. Aboard USS Thunderbolt, Admiral Henderson watched his fire control teams make their final preparations. The ship's main battery had been trained out to starboard, the massive 16-inch rifles elevated to their computed firing angle.
In the plotting room, deep within the vessel, mechanical computers whirred and clicked as they processed targeting data fed to them by radar operators and rangefinders. Captain Mitchell stood beside the main battery director, his eyes fixed on the range and bearing displays that would guide their opening salvo. The target selection had been made weeks earlier during the mission planning phase. Rather than attempting to neutralize the fortress's guns immediately, Hedgerson's plan called for systematically destroying the infrastructure that supported them. The first target would be the main ammunition bunker, a massive concrete structure buried 50 feet below ground level. Intelligence estimates suggested that this facility held over 80% of the fortress's heavy shells. Its destruction would effectively disarm the coastal defense guns regardless of any damage to the weapons themselves. At precisely 0600 hours, Henderson gave the order that would change everything. Commence firing. The words were transmitted throughout the task force, reaching every gunnery station on every ship. Captain Mitchell repeated the order to his gun crews, and at 0601 hours, USS Thunderbolt fired the first shot in the most devastating naval bombardment in history. The sound was indescribable. Even crew members who had served through dozens of naval engagements were stunned by the violence of the discharge. The entire ship seemed to leap sideways as the recoil from 9 16-inch guns firing simultaneously transferred over 1,000 tons of force to her hull. A tongue of flame over 100 feet long erupted from each barrel, followed by a shockwave that rippled across the water in all directions. The projectiles themselves were invisible in flight, their 2,700-pound mass moving at over 2,000 feet per second toward a target beyond the horizon. The shells followed a high arc through the thin air of the upper atmosphere, their trajectory calculated to bring them down at an optimal angle for maximum penetration. Each round carried more destructive power than entire artillery batteries of an earlier era, and their precision was guided by computational systems that represented the cutting edge of 1944 technology. On Kaigun-jima, the first indication of incoming fire came not from visual observation, but from the fortress's seismic detection equipment. Sensors designed to detect underground explosions registered the massive shock waves transmitted through the earth from the American ship's gun discharges. The 30-second flight time of the shells gave the defenders just enough warning to realize they were under attack, but not nearly enough time to take effective countermeasures. The first salvo struck at 0601 hours and 32 seconds. 9 shells, each following a slightly different trajectory, but all aimed at the same target, impacted within a 50-yard circle centered on the main ammunition bunker. The results were unlike anything previously seen in naval warfare. Rather than the surface explosions that characterized conventional bombardment, these projectiles drove deep into the earth before detonating. The combined force of their explosions created a seismic event equivalent to a moderate earthquake. The ammunition bunker, designed to withstand direct hits from the heaviest conventional shells, simply vanished. The hardened concrete walls, reinforced steel framework, and 50 feet of solid rock overhead offered no protection against weapons that delivered their explosive force from within. The bunker's destruction created a crater over 200 feet across and 60 feet deep, while shockwaves from the explosion damaged structures throughout the underground complex. Colonel Yamamoto felt the impact in his command post half a mile away. The reinforced concrete floor beneath his feet jumped upward, light fixtures swayed violently, and dust cascaded from the ceiling. Emergency lighting flickered on as the main electrical systems, damaged by the seismic shock, went offline. Reports began flooding in from throughout the fortress, but the scale of the destruction was so unprecedented that many observers could not accurately describe what they had witnessed. The psychological impact on the garrison was immediate and devastating. These men had absolute faith in their fortress's invulnerability, based on 3 years of successful defense against every form of attack the Americans had previously attempted.
The sudden, total destruction of their most heavily protected facility shattered that confidence in an instant. Many defenders, veterans of years of combat, found themselves paralyzed by the realization that their enemy possessed weapons against which their defenses offered no protection. Henderson's second salvo followed within 3 minutes, targeting the main power plant that supplied electricity to the fortress's defensive systems. The power plant, like the ammunition bunker, had been built to withstand conventional attack. Its generators were underground and protected by concrete.
Housed in reinforced concrete chambers buried deep underground, with massive blast doors protecting the entrance tunnels and redundant systems ensuring continued operation even under the heaviest bombardment, the 9 shells of the second salvo achieved the same precision as the first, landing within 40 yards of their target despite the 32-mile range. Their penetrating warheads drove through rock and concrete as if it were soft earth, delivering their explosive charges directly into the heart of the power complex. The destruction was so complete that secondary explosions from fuel storage tanks continued for over an hour, sending columns of black smoke high into the morning sky. With the fortress's main electrical systems destroyed, emergency lighting cast eerie shadows throughout the underground complex. Communication systems dependent on electrical power began failing throughout the installation. Radar screens went dark, radio transmitters fell silent, and the mechanical systems that elevated shells to the coastal defense guns ground to a halt. Within 6 minutes of the bombardment's beginning, Kaigun-jima had been transformed from a modern fortress into a collection of isolated strongpoints with no central coordination. The third salvo targeted the main communications center, the nerve system that allowed the fortress to coordinate its defenses and maintain contact with the outside world. This facility, buried even deeper than the ammunition bunker, had been considered absolutely secure against any conceivable attack. Its destruction severed the fortress's connection to the broader Japanese defensive network and left individual gun positions fighting blind, with no information about the enemy's location or intentions. Colonel Yamamoto, trapped in his command post with no electrical power and failing communications, found himself commanding a fortress that no longer existed as a coherent defensive system. Individual gun positions might still be operational, but without central fire control, ammunition supplies, or communication between positions, they could offer only token resistance. The systematic precision of the American attack had accomplished in 15 minutes what months of conventional bombardment might not have achieved. Captain Mitchell, observing the bombardment's effects through powerful telescopes, was amazed by the accuracy his ships were achieving. The new fire control systems were performing even better than their designers had hoped, placing salvo after salvo exactly on target despite the extreme range. Each impact created massive destruction that was visible even from 30 miles away, sending columns of smoke and debris high into the air. The fourth and fifth salvos targeted secondary facilities, the radar installations that provided early warning, the workshops that maintained the fortress's equipment, and the fuel storage areas that powered its generators. Each target was systematically destroyed with the same devastating precision that had characterized the opening shots. By 0620 hours, less than 20 minutes after the bombardment began, Kaigun-jima had been reduced from an impregnable fortress to a collection of isolated defensive positions with no central coordination or logistical support. The defenders who survived these initial attacks found themselves in a situation no military planner had anticipated. Their fortress, the symbol of Japanese defensive prowess, was being dismantled piece by piece by an enemy they could not even see. The massive coastal defense guns, designed to engage enemy ships at close range, could not elevate sufficiently to engage targets at 30-mile distances. Even if they could, their fire control systems had been destroyed in the opening minutes of the bombardment. Some gun crews attempted to return fire anyway, firing their massive shells on general bearings toward the distant American task force. These shots, fired without proper fire control data and at extreme range, fell harmlessly into the ocean miles short of their targets. The futility of their response only emphasized how deadly effective the American attack had been. Fortress Kaigun-jima, the symbol of Japanese defensive prowess, had been dismantled in a span of a few minutes, primarily because of the Americans' new system of fire control.
Completely, the nature of naval warfare had been transformed by American technological innovation. Henderson's sixth salvo marked a shift in targeting philosophy. With the fortress's infrastructure destroyed, he turned his attention to the defensive positions themselves. The coastal defense guns, no longer supplied with ammunition or fire control data, were systematically engaged and destroyed. Each gun position, despite its massive concrete protection, was obliterated by the precision application of overwhelming force. The bombardment continued for 2 more hours, with American shells methodically destroying every significant structure on the island. Barracks, hospitals, supply depots, communication facilities, and individual defensive positions were all targeted and eliminated with the same devastating effectiveness. The precision of the fire was so accurate that Henderson's ships expended fewer than 300 rounds to accomplish destruction that would have required thousands of conventional shells. By 0800 hours, the bombardment was complete. Kaigun-jima, the fortress that could not fall, lay in ruins. Not a single significant defensive structure remained intact. Not a single heavy gun was still operational. The island that had once bristled with defensive installations now resembled the surface of the moon, pocked with enormous craters and littered with twisted metal and broken concrete. The few survivors of the garrison, those fortunate enough to have been in the deepest and most protected positions when the bombardment began, emerged from their shelters to find their world transformed beyond recognition. The fortress they had believed invincible had been reduced to rubble in less than 3 hours, destroyed by an enemy they had never even seen. The silence that followed the bombardment was more unsettling than the violence that had preceded it. For 3 hours, the Pacific had trembled with the thunder of American naval guns. Now, as the last echoes faded across the water, an eerie quiet settled over the scene. Smoke rose from dozens of impact craters on what had once been Kaigun-jima, while debris continued to rain down from the massive explosions that had torn the island apart. Admiral Henderson lowered his binoculars and turned to Captain Mitchell. The devastation visible even at 32 miles was beyond anything either man had witnessed in decades of naval service. Where once a fortress had crowned the volcanic peak, only scattered concrete fragments and twisted steel remained. The systematic precision of their attack had achieved results that seemed almost impossible, even to those who had planned and executed it. The cost of this unprecedented victory was measured not in American casualties, which numbered exactly 0, but in the ammunition expended and the months of preparation that had made it possible. Henderson's task force had fired 284 of the revolutionary bunker buster shells, each representing thousands of hours of research, development, and manufacturing. The total cost of the ammunition alone exceeded the construction budget of a heavy cruiser, yet the results justified every dollar spent. More significantly, the bombardment had consumed nearly 18 months of intensive preparation. The development of the penetrating shells had required collaboration between naval ordnance experts, university physicists, and industrial engineers across a dozen different facilities. The fire control systems that guided them to their targets represented advances in mechanical computation that would influence civilian technology for decades to come. The meteorological analysis, intelligence gathering, and tactical planning had involved hundreds of specialists working in complete secrecy. The human toll on the defending garrison was catastrophic, but not total. Of 1,847 men who had manned the fortress at dawn, fewer than 200 survived the bombardment. Most casualties occurred not from direct hits, but from the secondary effects of the massive explosions, structural collapse, fires, and the toxic gases released when ammunition bunkers detonated.
Survivors, many suffering from severe injuries and all traumatized by the unprecedented destruction they had witnessed, faced a grim reality. Their fortress was gone, their mission had failed, and their emperor's promise of invincibility had proven hollow. Among the survivors was Colonel Yamamoto, pulled from the rubble of his command post by rescue parties hours after the bombardment ended. Physically, he had suffered only minor injuries, protected by the deep underground location of his headquarters. Psychologically, the impact was far more severe. The methodical precision with which his fortress had been dismantled challenged everything he had believed about modern warfare. These were not random explosions scattered across his defenses, but surgical strikes that had eliminated specific targets with devastating accuracy. The colonel's first coherent words after his rescue revealed the depth of his shock. "How could they know?" he asked repeatedly, referring not just to the American knowledge of his fortress's layout, but to their apparent understanding of exactly how to destroy each critical system. The systematic nature of the attack suggested intelligence gathering far beyond what conventional reconnaissance could provide. Someone had studied his defenses in minute detail and devised weapons specifically designed to defeat them. The broader implications of Kaigun-jima's fall reverberated throughout the Pacific theater within hours. Japanese naval headquarters in Tokyo received the first fragmentary reports by emergency radio, transmitted by one of the few communication systems that had survived the bombardment. Initial messages were so garbled and incredible that staff officers dismissed them as the confused ramblings of shell-shocked survivors. No fortress could be completely destroyed in 3 hours. No enemy possessed weapons capable of such precision at extreme range. Confirmation came from multiple sources over the following days. Reconnaissance aircraft flying over the island returned with photographs that stunned military analysts. The fortress that had anchored Japan's outer defensive perimeter simply no longer existed. Every major installation had been reduced to rubble with a thoroughness that conventional bombing could not have achieved in months of sustained attack. The strategic implications were staggering and immediate. For American military planners, the success at Kaigun-jima opened possibilities that had seemed impossible just days before. Fortress positions that would have required massive amphibious assaults costing thousands of casualties could now be neutralized by naval bombardment alone. The calculus of Pacific warfare had been fundamentally altered. Operations that had been delayed or canceled due to the anticipated cost in lives could now be reconsidered with completely different parameters. The technological innovations demonstrated in the bombardment spread rapidly throughout the American military establishment. Within weeks, every battleship in the Pacific Fleet was being retrofitted with the new fire control systems and supplied with penetrating ammunition. The techniques pioneered by Henderson's task force became standard doctrine for engaging fortified positions. Training programs were established to teach gunnery officers the precise methods required for effective long-range bombardment of hardened targets. The development of the bunker-buster shells had required solving fundamental problems in metallurgy, explosives chemistry, and ballistics. The hardened steel penetrators needed to punch through concrete and rock without shattering on impact. The delayed action fuses had to survive tremendous deceleration forces while remaining accurate enough to detonate at precisely the right depth. The explosive charges themselves were formulated to generate shockwaves that would cause maximum structural damage in confined spaces. Each of these technical challenges had pushed American industrial capacity to new limits. Specialty steel foundries had developed new alloys specifically for the penetrator heads. Chemical and munitions companies had developed new explosives with viable fuses. The development of these weapons was essential to the delivery of the strategy, and the successful usage of these weapons by Henderson's task force signaled a new era in the scale of naval bombardment. What was done at Kaigun-jima would inspire even further advancements in these areas. The Japanese had created a fortress that they thought was impregnable, but in the process of erecting their defenses, they had created the perfect target.
Companies had created explosive compounds that had never existed before. Electronics manufacturers had built fusing mechanisms that operated reliably under conditions no previous weapon had been expected to survive. The project had consumed resources and expertise from across the entire American defense industry. The fire control systems were equally revolutionary. Traditional naval gunnery had relied primarily on visual observation and relatively simple mathematical calculations. Engaging targets at 30-mile ranges required accounting for variables that most gunners had never considered. Atmospheric pressure variations, wind speeds at different altitudes, the Coriolis effect caused by Earth's rotation, and even the gravitational anomalies caused by local geology. The mechanical computers that processed this data represented the cutting edge of 1944 technology. Captain Mitchell had spent months learning to operate these systems, working closely with civilian engineers and mathematicians who understood their theoretical principles but had never used them in combat. The integration of radar ranging, ballistic computation, and precise gun laying required skills that bridged the gap between traditional seamanship and modern engineering. Mitchell's success at Kaigun-jima established him as one of the foremost experts in precision naval gunnery, a field that had essentially been invented during the operation. The strategic impact of the bombardment extended far beyond the destruction of a single fortress. Japanese defensive doctrine throughout the Pacific had been based on the assumption that well-constructed fortifications could exact such a heavy toll on attacking forces that American public opinion would eventually force a negotiated peace. The demonstration that even the strongest defenses could be neutralized without significant American casualties undermined this entire strategy. Within the Japanese military hierarchy, the fall of Kaigun-jima triggered a crisis of confidence that reached the highest levels of command. If their most advanced fortress could be destroyed so easily, what hope did their other defensive positions have? Intelligence reports suggested that the Americans were already applying their new techniques to other targets, systematically dismantling fortress positions that had been considered impregnable just weeks before. The psychological impact on Japanese forces throughout the Pacific was profound and immediate. Garrisons that had maintained high morale based on their confidence in their defenses suddenly faced the reality that their positions might be destroyed at any moment by an enemy they could not even see. Requests for reinforcement and resupply increased dramatically, while reports of declining morale became commonplace. The myth of the invincible fortress, so crucial to Japanese defensive planning, had been shattered in a single morning. American intelligence services quickly recognized the broader implications of their success. Intercepted Japanese communications revealed the extent of enemy demoralization and the urgent efforts to develop countermeasures. Japanese engineers were desperately trying to redesign their fortifications to resist the new American weapons, but the fundamental physics of the problem offered no easy solutions. Defenses strong enough to stop penetrating shells would require resources Japan no longer possessed and time they did not have. The innovation cycle triggered by Kaigun-jima accelerated throughout the remainder of the Pacific Campaign. American forces encountered new types of Japanese defenses, designed specifically to counter penetrating munitions. These defenses, in turn, drove further American innovation in shell design, fusing technology, and targeting methods. The technological arms race that began with Henderson's bombardment continued until the end of the war, with each side constantly adapting to the other's developments. The human stories emerging from the bombardment revealed both the horror and the heroism present in modern warfare. Among the American crews, the initial tensions had quickly given way to a sense of confidence. They witnessed firsthand the devastating power of their new weapons and understood that they were participating in something significant. Successful engagement became a source of immense professional pride. These men had participated in something genuinely revolutionary, proving that American ingenuity and industrial capacity could overcome any defensive position the enemy might construct. Their letters home, heavily censored but still revealing, conveyed both satisfaction at their success and soberness about the destruction they had witnessed. Petty Officer Second Class Robert Chen, a fire control technician aboard USS Thunderbolt, wrote to his family in San Francisco about the incredible precision of the bombardment. Chen, whose parents had emigrated from China 2 decades earlier, saw his participation in the operation as both a professional accomplishment and a contribution to the broader fight against fascism. His technical expertise, developed through months of intensive training, had helped guide American shells to their targets with unprecedented accuracy. The diversity of Henderson's crews reflected the democratic nature of the American war effort. Men from every background and region had contributed their skills to the operation's success. Farm boys from Iowa operated sophisticated radar equipment alongside urban mechanics who maintained the complex machinery. Recent immigrants worked beside families that had been in America for generations, all united by their commitment to defeating an enemy that threatened the principles they fought to defend. The aftermath of the bombardment also revealed the limits of technological solutions to strategic problems. While the destruction of Kaigun-jima had been complete and devastating, it represented only one fortress among hundreds scattered across the Pacific. The techniques developed for the operation would need to be applied systematically to dozens of similar targets before American forces could advance toward the Japanese home islands. Each engagement would require the same meticulous planning, specialized ammunition, and precise execution that had characterized the original attack. Supply lines became a critical concern as American forces began applying their new bombardment techniques more widely. The specialized shells required for penetrating fortified targets consumed far more resources than conventional ammunition. Each bunker buster round required rare materials and complex manufacturing processes that limited production capacity. Ammunition ships carrying these weapons became high-priority targets for Japanese submarines and aircraft, forcing significant changes in convoy routing and protection. The training implications were equally significant. Every gunnery officer in the Pacific Fleet needed instruction in the new techniques. Fire control technicians required education in the operation of complex computational equipment. Even basic seamen needed to understand the different handling requirements for the heavy penetrating shells. Training centers from Pearl Harbor to San Diego worked overtime to prepare personnel for the new type of warfare that Kaigun-jima had inaugurated. Japanese attempts to counter the American technological advantage revealed both ingenuity and desperation. Intelligence reports described fortress positions being redesigned with multiple layers of protection, decoy installations designed to draw fire away from critical facilities, and underground bunkers built so deeply that even penetrating shells could not reach them. These defensive innovations, while creative, consumed enormous resources and manpower that Japan could ill afford in late 1944. Up next, you've got 2 more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out.